weekend of the British Grand Prix, we're at Silverstone for a race with a difference. We go back in time to show off some electrifying classics.
And I'm at Goodwood Race Circuit to see if I can drive around this historic track using just my head.
Silverstone is the home of British motorsport, and I'm here at the Brit Championship. But this is a race with a difference, as one team is made up entirely of drivers who have some form of disability. But thanks to a bit of technology, they have serious hopes of taking home the silver. More on that in a few minutes, but where's Spencer? I said Silverstone. Are you lost?
No, I've had an invitation that I could not refuse from another race outfit here at Goodwood. Now, we've got the whole circuit to ourselves today, so I'm going to be on this track later putting some brand new assistive tech to the test at racing speeds.
Just don't go breaking anything.
I'll try not to.
Here in Silverstone, things are busier and noisier, and that's because everyone here is racing for real. And we've been invited into Team Brit's garage, so Paul is over there having a nose about and hopefully can tell us more.
Nosing about is what I do best, and here at the home of British motor racing in Silverstone, there's certainly lots to see. But specifically, I'm here to meet Team Brit, a competitive motorsport team with a difference. They're made up of 6 disabled drivers using bespoke, specially adapted cars to compete in races against non-disabled drivers on a level playing field. My visit came during testing ahead of the latest round of the Brit Championship. Aaron Morgan is one of Team Brit's 2 drivers in the endurance event, driving an Aston Martin GT4. Aaron became a wheelchair user in 2006 following a motocross accident. The disabled drivers on the team use control systems developed by engineers in-house.
These are completely sort of bespoke, completely developed from the ground up by Team Brit. You know, Dave and the other engineers within the team said, right, we've got this problem. You know, this is what we need to achieve, and this is the solution they come up with, and it's by far the best in the world.
The controls link to a system of actuators and sophisticated electronic systems to drive the vehicle.
So Aaron, can you just explain to me a little bit about how the hand controls work and how you use them to drive the car?
Yeah, of course. So with the accelerator, you just pull this paddle here, and obviously, you know, there's various levels of throttle you can apply there. On the other side is the brake paddle, which works in exactly the same way, so you can modulate it. And then these grey buttons inside the steering wheel to operate the gears. Now the way the car's set up, you have the upshift on the left side. So whilst you're on full throttle with your right hand, you've then got your left hand to change the gears. And then it's vice versa for braking as well. So whilst you're braking with your left hand, you can go down the gears with your right hand.
The key thing about these controls is that they're designed to be used by drivers with a range of impairments. These could be driven by someone with only the use of one arm, for example. Aaron's teammate in this event is autistic, and the car remains drivable by him in the usual way, as the adaptations coexist alongside the regular controls. Hand controls per se aren't new, I use them to drive my car, but these are quite different to what you might find on a road car, as they're tuned for a racing environment. But a racing team is more than just the drivers, and building systems like this into already finely tuned machines isn't a straightforward process.
And so you obviously work with different iterations of these controls. How does that process work, and how did you get to where you are now?
Well, first of all, we start with looking at the drivers and seeing what their needs are, you know, what their disabilities and what physical limitations they've then got. And then we start from there with the ergonomics of the control system that we're designing. And by that I mean the paddles that are on the steering wheel. And when we started designing this, we started with a very different steering wheel to the one we've got now, so we're constantly improving it and developing it based on driver feedback. Definitely challenges there, and a lot of that's in integrating our system with the car's system. Cars aren't particularly good at tolerating other things being added into the network. And so we do have that challenge, but we love it. You know, that's part of what we do, and it's why we do it.
Team Brit's ultimate aim is to make racing history and take a team to the world-famous Le Mans 24-hour endurance race, becoming the first ever British all-disabled team to do so. So what are the team's goals for this year?
The aim for this season is to win the Brit Car Endurance Championship within our class. We're well up there within the championship. We've achieved 2 class wins so far this season, hoping for another one here this weekend at Silverstone.
Paul there with a look at the tech, and I'm joined by Lucy Sheehan, one of the professionals behind Team Brit. Tell me, why is today so important?
Today's so important. So today is about getting ready for the racing, and that is what we have to do so well. We are not here to make up the numbers. We're competing against able-bodied racers on a completely level playing field. So the tech has to be right, the car setup has to be right, drivers have to be comfortable. We've taken home silverware in all 3 races so far this year, and we want to do it again this weekend.
Wow, and we've seen what great access the company gives to people with some driving experience. But how about for anyone with a disability? How accessible is this really?
There are loads of different ways they can get involved, and we can help them. So from karting, real grassroots motorsport, through to track day experiences that we can offer them where they practice on the simulator first. We give them help and support to get used to our hand control technology, then they get out on the track. So it's a staged approach, and we're there with them all the way. And of course there's the money as well, because motorsport is not cheap. So for a full season's racing, you're looking at about £15,000 as a starter, which will put a lot of people off, but we help them with that, and there are ways in. So definitely the door is open in ways it's never been before. So please, we'd love people to get in touch and find out more.
Great, just need some skills and sponsorship. Lucy, thank you very much. Right, time now to connect up to Goodwood Racetrack where Spencer is.
Hey Laura, that looked great. It's amazing how the opportunity to race is just opening up to more and more people.
Where are you exactly?
Yeah, funny story. This is a look of part amazement and part terror. I'm a passenger in a modified Chevrolet Corvette C8 Stingray, but it's who's driving and how he's driving that is blowing my mind. We've met Sam Schmidt before. He's a racing driver who was paralysed in an accident in 2000. And 5 years ago, he took us for a ride through Las Vegas in a car that allowed him to drive using just his head and his mouth.
So the steering system, it's an IR camera system. Whichever way you turn your head steers the car. We turn his head angle into a steering angle. The gas and brake, it's a sip and puff system, so we have a tube connected to a pressure sensor. Positive pressure, blowing, that's your accelerator pedal. Negative pressure, sipping, that's your brake pedal.
The Sam car is legal to drive in the US, and Sam has a driver's license. And since 2016, the system has been fine-tuned so that it's now not only safe and responsive enough to drive at road speeds, but at race speeds. 123, 128, 128, wow. In fact, Sam has taken this car up to 201 miles per hour. Not today though. Anyway, the reality is that operating equipment without using arms or legs has many more applications than just on the racetrack.
Where I also see this technology being very beneficial is in the workplace. Industrial applications, forklifts, harvesters, trains. I mean, it's kind of scary, but I could operate a train, sitting in my living room with this technology. So I would really like to see disabled veterans and people of all disabilities have an opportunity to go back to work. And many of them just want to be a productive member of society and haven't been given the opportunity or the technology to do it.
I mean, can I just say, that was incredible. That you are just incredible.
I think really you should try the car from over here with my controls.
Okay, I'm happy to do that, but not at that speed. Well, this is a first. What an honour, what a thrill, what a potential humiliation.
To drive the car, you're going to point your nose where you want to go. And don't lean. Leaning's not going to work. You actually have to rotate your head.
Wow.
Ready to give it a shot?
I'm ready to give it a shot.
I'm just going to let it go and then start puffing.
And here's the thing. From pretty much the start of the first lap, I get it. It does take a lot of concentration, but as long as I stay focused, Sam's car looks after me.
Well, how was it? You gonna take my job away?
That was pretty emotional for me because actually it wasn't as hard as I thought it was going to be. And so it kind of shows how this kind of control system could be used by ordinary people who aren't mad racing drivers. I need a few more laps. Honestly, that was incredible, but also really hard. I'm actually a much better driver than that with normal controls, I promise you.
Well, I think that's a challenge then. Why don't you do a lap with the normal controls? I'll use my controls. We'll see who's faster.
Can I phone a friend?
Oh, hi.
Hey, Lara. So, yeah, it's me. Sam's just challenged me to do a lap of the track, me using standard controls and Sam using his controls to see who's fastest. What do you think?
My money's on him. He is a race car driver. You do know that, don't you?
Yes, I am aware of that, thank you. Right, well, wish me luck.
Good luck, and don't break anything.
Yeah, you said that last time.
We're here at the Brit Car Championship while Spencer is getting ready for the race of his life down in Goodwood, and we'll be catching up with him in just a bit. In a moment, we want to talk space tech and show you the secret life of a lab technician at MIT. But right now, we're not leaving trackside. Well, a little bit. It's kind of over there. Jen's there somewhere, taking a look at a local company that's transforming old cars. And it has a bit of a famous fan.
I'm also here at Silverstone, and we're about to go into the Lunas workshop where they're re-engineering classic cars into electric cars. It's incredible in here. There's so many beautiful cars. Lunas is making the world's first fully electric Rolls-Royces and Bentleys. There are about 18 classic cars in the building, most dating from the 1960s. John Hilton is the technical lead here. He was an aeronautical engineer at Rolls-Royce before moving into Formula One. Among a long list of accomplishments, he was technical lead for Michael Schumacher's 1994 World Championship win. What do you actually do? So you're converting this car into an electric vehicle from a petrol engine.
So this car has a petrol engine in today. We'll be removing the engine, the gearbox, the fuel system, the exhaust system and all the things that make the engine work and replacing those with a brand new electric powertrain.
The full renovation of the car takes around 26 weeks, and for Rolls-Royces and Bentleys, the cost of the work starts at around £350,000.
It can be very much more expensive if you want to start with a much rarer donor such as this drophead car.
How much would this car cost to buy?
So the petrol versions of this are regularly going for sort of 350,000.
Wow, so 700,000 once you're done.
Yep. So yes, we have a number of other beautiful cars here. So it's the big Rolls-Royce Phantom 5, the Bumblebee as we call it colloquially. The fastbacks, they're very rare. In fact, that's the only one I've ever seen.
How much would that cost?
Not far off £1 million. This was in a James Bond movie.
Wow.
You know, these are absolutely incredible vehicles when you look under the skin and how they were built. And, this Rolls-Royce is from 1961. The craftsmanship within this build is just incredible. But when you look at the clientele base, it's across the board. It's people that want an electric Rolls-Royce and there isn't a new alternative currently. Or it's people that have an absolute love for the classics and have never wanted to go down that usability journey and the drivability of these vehicles.
One investor who has been captivated by the conversion of classic cars into electric vehicles is former England football star David Beckham. He's taken a 10% stake in the company.
And it's not just the classic cars that are getting a new lease on life here. This recycling lorry would have to be decommissioned in 2025 because of its diesel engine, and now it's being fitted with an electric motor.
You've got 2 billion vehicles on this planet, and we're doing a transition to EV. We cannot look at scrapping these vehicles. You know, that vehicle that you've seen there is absolutely in great condition. That is a perfect candidate to be re-engineered for an EV future. And we're looking at all vehicle classes where we believe re-engineering the vehicle is a better choice than the buy it new mentality that it's so embedded into us.
And Range Rovers are being made over too.
The Range Rovers, obviously, they're famous for their off-road capability, and we're maintaining all of that. So they're still four-wheel drive. We're keeping low ratio gearbox. They will still climb steep hills and all those things Range Rovers can do. It will be fast, much faster than standard. We're building this with 375 horsepower electric, 220 or so, and smooth and quiet, and a good range. We're expecting more than 200 miles.
Yeah, so the absolute key here is we're moving to a clean air quality future. And I think we all saw it in this past year. It's a fantastic shift that we're now making, and we should all be playing our part within that. And as you see vehicles move away from diesel and petrol, the world's going to be a better place.
Hi, my name is Paula de Valle Pereira. My master's receipt is right there.
Welcome to the Star Lab.
Here we build shoebox-sized satellites called CubeSat. They cost a fraction of traditional satellites, so we can launch many more satellites into space, collecting a lot more data. That allows us to track global warming and interplanetary life more accurately. These networks could also bring wider spread, faster internet coverage across the world. Some CubeSats now use super-fast communication lasers to interact with each other. These liquid-filled lenses can bend light by 90 degrees, so the information sent can travel more directly between CubeSats. Of course, lasers need power to operate, which is why we build another solution. This project is called FLAP, the Folded Lightweight Actuated Position System. This hinge bends when heated, so we can angle our satellite solar panels to collect maximum energy from the sun.
3, 2, 1, starting test.
This joint can also direct tools like antennas or cameras. Materials often behave differently in space, so I tested this in zero gravity. Planes like this recreate the weightless atmosphere of space by dropping several miles in altitude in a matter of seconds. This is a replica of Demi, a Starlab CubeSat that's already in space. Demi's mirrors reflect distracting, unwanted light away, giving scientists a better look at faraway planets. The Demi is tracked by our rooftop antenna, so we can see when it's closest to Boston to send commands or collect data from it. So we could find life outside our planet for the first time in the next few decades. Our goal now is to have new Starlab satellites launched every couple of years. Thank you so much for joining us in our lab tour today.
Right, earlier on I met Sam Schmidt, who's taken me for a few laps at Goodwood, hitting 128 miles an hour using just his head and his mouth. And now he's challenged me to do a faster lap than him. Me with conventional controls and him with his controls. If this goes wrong, make sure they edit it kindly, won't you, Lara?
I've spoken to some of the team here and they say, you know the black stuff on the track?
Yeah.
stay on that.
Thanks. All right, wish me luck. See, in my mind, this isn't a foregone conclusion. In some ways, I have an advantage. I know this circuit, and I'm using the same controls that I have for my entire adult life.
All right.
Hi. Well, how'd I do?
150.
150. Is that good?
Respectable.
So let's see if Sam can beat my flying lap of 1 minute 50. Well, the very best of luck, sir. Confidence?
Don't really need it, but okay.
I mean, it's honest. So, you know that bit about it not being a foregone conclusion? Yeah, I don't stand a chance.
Right back at the first meeting, we knew it was going to take months. We knew it was going to take a lot of commitment from the engineers, resources from Aero, and my time. And they thought it was funny. After an hour, I said, look, guys, I'm very interested, but not unless we can go 100 miles an hour, you know.
You won. Congratulations, 145. I mean, there was kind of no contest really, was it? How do you feel being able to do this?
You know, it's so, I guess the best word I can use is freedom. You know, just, I'm in total control, and there's very few things in my life that I have control over, you know, and to be able to steer and gas and brake, just like the old days.
Sam, thanks for being so inspiring. I've got to make a call now and let someone know how I did.
Thanks, Spencer. Uh-oh.
Hey, Lara. Yeah, Sam beat me. Not a surprise, really, when you think about it.
No, but you did well. How do you feel?
I feel inspired, very humble, a bit sick, and glad it's over. Anyway, I'll see you later. That is it for this week. Thank you so much for watching.
As ever, you can keep up with the team on social media. Find us on YouTube, Instagram, Facebook and Twitter at BBC Click.
Thanks for watching, and we'll see you soon.